Thank you. Good afternoon, everybody. So my topic today is the use of augmented reality technology to enhance comprehension of steel structure construction. That's the agenda today. I have a couple of definitions of augmented reality, augmentation, and augmented reality technology. Just define the context. The pedagogical function of AR is simple. As AR continues to gain popularity, it's crucial to study the ability of technologies to impact education. So basically, in this process, we created what we call a virtual field trip. Because the problem with field trips is projects may not be at the right point in time on topics you want to present. So you record all this, and then you can use it in future classes. And the virtual objects allow us to make obscure information evident to human perception. The comprehension we developed with augmented reality technology is that it integrates site visits to the classroom. It provides greater insight to students. It dispenses a more effective learning experience, and it prepares them for successful careers in construction. Not using the AR gives them inadequate exposure to construction techniques and how things are built in the field, and that's why we use this technology. So the research goals and objectives were to assess the impact of augmented reality technology as a mechanism to simulate the environmental context of construction processes and construction management, educational experiences, to evaluate the impact of AR on learning outcomes in construction management, education, and the hypothesis is that the use of augmented reality will enhance students' comprehension of the spatio-temporal constraints prevalent in steel structure construction process. Okay. So the methodology is, as you can see up there, the selected target audience was undergraduate students enrolled in an accredited construction management program. For the purpose of the research, data analyzed was based on the sampling of students enrolled in the Rinker School of Construction Management at the University of Florida. The experiential procedure was conducted with students in their second semester of their junior year in the program over a period of 2 academic years. Estimating one class was selected for this implementation of the study of structural steel, and a total of 55 students participated in the study. So the building we looked at was a building on campus. It was a multi-story academic classroom, an office building. It had a structural steel frame, masonry exterior walls, brick veneer facing, clay tile roof system. The way we documented the project was daily site activities, and through collaboration with the contractor, we had still images, video data from cameras as well as drones. So we gathered multiple data streams from several vantage points. And then we set out a plan to overlay virtual objects on the job site. You can see here some of the objects we created and overlaid. We had to make decisions on media selection, screening, and quality control. We used a variety of software tracking packages, including camera tracking software. That way we can pose the camera angle in our augmentation and match the camera angle of the drone or regular camera. We used 3D modeling software, and we also used video editing software. So in the case of the media selection, we identify what data was to be represented based on content and level of visible detail in the videos. The screening, the selected media for quality, we had to screen we had a lot of footage and images. We had to separate them and screen them for quality, and the quality control system was developed. The camera tracking software was used to process the video, defining the camera path, and that way we can augment the reality using the same path. We used the 3D modeling software to begin the process of combining the visual media and virtual objects, and the video editing software was used to combine all the videos we took. The augmented reality development emphasized 3 areas: the foundation footing, structural columns, and structural framing. These elements were identified as the components of structural steel assemblies the student always had problems with identifying. And these are students with zero field experience had more problems than students that had some field experience, obviously. The model shows the assembly and installation sequence in situ, on site. So we had 3 test groups: a group A, a group B, and a group C. The group A just looked at the videos. The group B looked at only had the regular lectures and was the control group, and group C had the lecture as well as the videos. So we did a pre-test to assess their knowledge before they went to the process, and it was completed at the beginning of the semester before they learned anything in the class. The participants were provided with a simple parametric 3D view of the sample project, and they were asked to label and identify all the components of that assembly. The post-learning process, we assessed the impact of the video instructional tools used, and it was a post-test, so we looked at the test results for all 3 groups. They had qualitative and estimating assignments completed using a set of construction drawings for the portion of the test case building. The focal points, so looking at the result, you can see the analysis on the right-hand side. The focus point of the analysis was the identification of tasks required to build the structural steel assembly and to installation sequence of the identified tasks. So they had to know how the structure was assembled. Comparison between the responses. So for the test question, for example, we said, for the list of possible tasks required to build a structural steel assembly generated in question 2, please organize and order the most suitable installation sequence within the construction process. So they had sequences randomly sorted, and they had to arrange them in the proper sequence. The null hypothesis postulates that there is no significant difference between the sample proportions, and the alternate hypothesis was that there was a significant difference, and we tested to a p of less than 0.005. So we found significant differences between the answers related to the concrete footings, the structural steel columns, and the connections. Visualization of job site conditions. The connection element was not highlighted in the videos. However, the video contained still image captures of those connections and of the iron workers installing the structural steel. The majority of the students identified the framing and the column related tasks by reason of the fact that the level of augmentation of the framing and columns was more advanced than the connections. So the students were able, by using the virtual models, we showed that there was a great impact on the students' spatio-temporal comprehension of the structural steel construction. So they were able to join time and components and see how things progressed on the job site. The group that benefited the most were the group that both had the regular lecture and the augmented reality videos. So in conclusion, by using augmented reality technology content in the classroom, we were able to get better performance and understanding by the students. So basically, like I said at the beginning, we introduced a virtual field trip component to help bring the students within the context of what they were making estimates of. ART is a possible solution to the comprehension deficiency of construction. We're taking all the students to the job site. May be impossible depending on the location of the job site, location of the university, urban versus a non-urban location, the availability of buildings. All of those are components. The virtual field trip here, it solves a lot of those problems. So our recommendation is that you need further studies to determine the effectiveness of this technology, and the scope. Limitations are we only have University of Florida students, so we don't know about the rest of the students. And our institutional research board required voluntary participation, so although there were students, they didn't have to participate. And there wasn't really a motivation to excel, right? Because this wasn't part of the graded event, it was just part of the study. So in the future, we'd like to have this at many institutions and maybe incorporate that as part of the grading in the classroom. And now we have time for questions.
Okay. Thank you very much.